Good morning to all of you. Today I am recording the lesson for the day 17. In the last class, we have been discussing about the problems on parallel law of forces and also on the resolution of forces. So we will continue to that one, and today we are going to solve some of the problems on the resolution of forces, and also we will study about the Lami's theorem and also problems on the Lami's theorem. So I'm sharing the PPT. So this is the other things. So we'll discuss about we'll cover the problems on the resultant of forces by resolution of forces, and also problems on Lami's theorem. Now, so already we have discussed about these problems in the last class, and in the last class the last problem was this is the problem. So this is the resultant of the two forces acting at a point are found by both methods, that is the parallel law of forces and also resolution of forces. In both cases we got the same answers. But however, the parallel law of forces will be applicable only when two forces are acting with some included angle between them, and when more than two forces are acting, then it is not possible to find out the resultant by parallel law of forces. Then we have to go by resolution of component methods, resolution of components of forces. Now this is a problem for today. So this is a problem. Take down this problem. So this is also problem on the resolution of forces. So in this way, in this case, we have to find out the magnitude and direction by the method of resolution of forces. Take down this problem. Find the magnitude and direction of the resultant of three forces acting at a point as shown in the figure. So here the three forces are given. The figure A is the given figure. Here three forces are acting. So for the first force, P force is acting to the rightwards, making an angle of 60 degrees with x-axis. The second force is the Q is equal to 200 newtons, acting leftward and making an angle of 30 degrees with the horizontal or x-axis. And the third force S is equal to 330 newtons, acting vertically downwards. So this is the given figure, that the given force system, and we are supposed to find out the both magnitude and direction of this given force system. So the given force system is drawn in the space diagram. Now in the figure B we have drawn the component diagram. Here the three forces are resolved into their components. That is P is resolved into pH, that is the horizontal component of P, and PV, that is the vertical component of P, and the force Q is resolved into two forces, QH, that is the horizontal component of Q, and QV, the vertical component of Q. And here the third force is the force S, and it is acting vertically downwards. The when a force is acting vertically downwards, that is a vertical force. For a vertical force, the horizontal component is equal to 0, and the vertical component of the vertical force is equal to the force itself. So it will be simply added in the algebraic sum of the vertical components of the forces. And whereas while calculating the horizontal components of the forces, so the horizontal component of this S will become the 0. So that you must note. So now for this problem, this is a given data. The three forces are given. P is equal to 170 newtons, Q is equal to 200 newtons, and S is equal to 330 newtons. Here the alpha 1, that is the angle of P, is equal to 60 degrees with horizontal, and alpha 2, that is the angle made with the force Q with horizontal, alpha 2 is equal to 30 degrees, and the third one is the vertical force S. So this is the given data. With this we have constructed the space diagram. Then after this we can move to the component diagram. So in this component diagram, the same forces, whatever the forces that are acting on a particle which I have shown in the space diagram, are redrawn with the same thing, and in addition to that we have to resolve the each force into their horizontal and vertical components. Here for the force P, the pH is acting rightward and it is positive. The value is equal to P into cos 60, and the vertical component PV is equal to P into sin 60, and it is acting also vertically upwards, so it is also positive. And because the force P is acting in the first quadrant, all are positive, the cos theta and sin theta also positive, therefore both are positive. Now coming to the force Q, when it is resolved, the QH is the horizontal component of the Q, that value is equal to Q into cos 30, because it is making an angle of 30 degrees with the horizontal. So the Q is making an angle of 30 degrees with the horizontal. So QH is equal to Q into cos 30, and but it is acting leftwards, that is in the negative x direction. So it is taken to be negative, and the vertical component of the Q is equal to Q into sin 30, and it is acting vertically upwards, so it is positive. So because the Q is acting in the on the other way also, because the Q is acting in the second quadrant, so in the second quadrant the sign is positive and cos is negative. Therefore the QB is positive and QH is negative. And for the force, yes, it is a vertical force. The horizontal component of this vertical force is 0, because S into cos 90 will become 0. Cos 90, because the cos 90 value is 0. And whereas the vertical component of S is equal to S into sin 90. We know that the sin 90 is equal to 1. Therefore, that is equal to S. S into 1 is equal to S. Therefore, the horizontal component of the vertical force is 0 here, and the vertical component of the vertical force is equal to the force itself, that is S value. And we must know that, again just I am repeating at this instance, the for a horizontal force there is no vertical component. So the vertical component of a horizontal force is equal to 0, and the horizontal component of the horizontal force is the force itself, and the horizontal component of a vertical force is 0, and the vertical component of a vertical force is equal to the force itself. Now based on this component diagram, you will find out the algebraic sum of the components of the forces. Now the resolving the forces horizontally, sigma h is equal to sum of the horizontal algebraic sum of the horizontal components. So the force P is equal to 170 and theta is equal to, that is alpha 1 is equal to 60. So 170 into cos 60, it is positive, and for the force Q, the value of Q is equal to 200 into cos 30, it is negative. So therefore 170 algebraic sum is equal to 170 into cos 60 minus 200 into cos 30. So here this is equal to 170 into 0.5 and 200 into 0.8660. So that is equal to, that is sigma h is equal to minus 88.2 newtons. Here we got a negative sign because the algebraic sum of the force is acting in the negative x direction, that is leftwards, that we must note. Next, similarly, to find out the algebraic sum of the vertical components of all the forces, resolving the forces vertically, the sigma v is equal to algebraic sum of the vertical components of all the forces. Here the vertical component will become, here for the PV. PV means the P into sin 60. That is the vertical component of the force P, and that is positive. And for the force Q, the Q into sin 30, and Q into sin 30, that is also acting upwards, so it is also positive. So PV plus QV. And here the third force, the vertical force. So the vertical component of the vertical force is equal to the force itself, that is S, but it is acting downward, so it is negative. So first two are the positive, PV and QV are positive, and S is negative here. So therefore the algebraic sum is equal to PV plus QV minus S. Here P is equal to 170 into sin 60 and also the plus 200 into sin 30 minus the S is equal to 330 because it is acting vertically downwards. So substituting the values, we will get the algebraic sum of the vertical forces. Sigma V is equal to minus 82.78 newtons. Here also we got the negative value because here this vertical component is acting downwards. So when it is acting downwards, it is taken to be negative because it is acting in the negative y direction. Therefore, so sigma V is equal to minus 82.78, that is minus 82.78 newtons, and acting downwards. Now we have to find out the resultant force. The magnitude of the resultant is the R is equal to under root of sigma h whole square plus sigma v whole square. So that is equal to 88.2 whole square plus 82.78 whole square. So here one thing is important. Either we can take the negative value or the positive value. The square of the value will become anyhow positive. So it does not matter whether we are taking the positive value or negative value, because the square of either positive value or negative value is only positive. Therefore automatically we will get the positive value, and R becomes, so when we calculate the square root of that one, the derived value, ultimately the resultant, the magnitude of the resultant force is equal to 120.96 newtons. So this is the magnitude, this much of force is acting. Now to find out the direction, so at what angle it is acting. So to find out that angle, we know that tan theta is equal to sigma v by sigma h, or theta is equal to tan inverse of sigma v by sigma h. So that is equal to tan inverse of 82.78 by 88.20. So ultimately the value of theta is equal to 43 degrees 11 minutes. So this is the angle. Here also we have not substituted the negative, because whether it is a positive value or negative value, we will get the same value of theta. But only thing is that positive and negative will be useful to decide the quadrant in which the resultant force is acting. Therefore, first we have to find out only theta. Theta is equal by just simply substituting the sigma v value and sigma h value without their signs. We will find out the angle. So that in this case, that angle is theta is equal to 43 degrees 11 minutes. Now, so we have to decide in which quadrant it is acting. So we know that sigma v also, in this case the sigma v also negative, and sigma h also negative. So when both the sin theta and cos theta are negative, so this is possible only in third quadrant. So that means the resultant is acting in the third quadrant. And what is the angle? So in the third angle, in the third quadrant, the resultant is making an angle of 43 degrees 11 minutes with x-axis. So in the third quadrant, so it is acting at an angle of 43 degrees 11 minutes. So this is the that means the resultant is acting in the, because you see here when the sigma h and sigma v both are negative, that means sigma h will act in the leftward and sigma v will act in the downwards. Therefore the r will act in the downwards and also in the leftward direction, leftwards and downward directions. So the third quadrant, the r is acting and making an angle of 43 degrees 11 minutes. So here in this case the answer is, so the resultant force of 120.96 newtons and acting at an angle of 43 degrees and 11 minutes with x-axis in the third quadrant. So this is the complete answer for the given problem. So in this way we have to work out the problems, and in deciding the direction of the resultant, so first we have to find out the angle theta, and depending on the signs of sigma h and sigma v, that is the cos theta and sin theta values, so whether it is positive or negative. Suppose if the both are positive, it will act in the first quadrant, and if the cos theta, that is sigma h, is negative and sigma v is positive, it will act in the second quadrant. If both are negative, that is sigma h and sigma v, that is cos theta and sin theta are negative, in that case, so this is the example of this problem, and in this case the resultant will act in the third quadrant. And in case if the sigma h is positive and sigma v is negative, that is cos theta is positive and sin theta is negative, so that is possible only in fourth quadrant. So like that the resultant will act, and however whatever may be the coordinate it is acting, so we will get the theta value. The theta must be only with x-axis. The amount of angle that we have taken is only from the x-axis. So like this we have to solve the other problems. Next we will go to the Ramey's theorem. So in the previous examples we have been discussing about the finding out of the resultant force when two forces are acting at a point, or three forces are acting, or even more than three forces are acting. If two forces are acting, then by making use of the parallelogram law of forces, we can find out the resultant. And if the forces are acting are more than two, that may be three or more than three, in that case by using the method of resolution, we will find out the resultant force. Now, so that is the case of the resultant. Now the Ramey's theorem. So this Ramey's theorem is a most important theorem, and it will describe the equilibrium condition. So here there is no question of the resultant. It will discuss only about the equilibrium condition. So as we know that what is the equilibrium condition? When some forces are acting on a body and the resultant force acting on the body is zero, then the forces acting on the body are said to be in equilibrium. That means this Lami's theorem is applicable when three forces are acting on a body and the resultant is equal to zero. So that is the first condition. So it is applicable to the equilibrium condition. That means when three forces are acting on a body and the forces are in rest condition, that is the forces are in the equilibrium condition. That means the resultant of the three forces is equal to zero. Then only it is applicable. And in that condition, it will say something. So that is called as the statement of the Lami's theorem. So first most important is the Lami's theorem is applicable when three forces are acting on a body and all the forces are in equilibrium condition. That means the resultant of all the three forces at that point is equal to 0. And in that condition, so we have a statement for this Lami's theorem. So when it states that the Lami's theorem states that when three forces are acting at a point or in equilibrium, then each force is proportional to the sine of the angle between the other two forces. So this is the statement. Here, when three forces are acting and we know the angle between the all the three forces, then the each force is proportional to the sine of the angle between the other two forces. That means here we got the three forces, say A, B, C. A, B, C are the three forces acting at point O, that is the meeting point. Now the alpha, beta and gamma are the angles between the forces. That means here the alpha is the, suppose the force, the angle between the B and C, and beta is the angle between the force A and C, and gamma is the angle between the force A and force B. In this condition, if all the forces acting at the point O are in equilibrium, in this condition, according to this Ramesh theorem, force A by sin alpha and force B by sin beta and force C by sin gamma. So here what is happening is the force A is proportional to the sin alpha and force B is proportional to the sin beta and force C is proportional to the sin gamma. That is, A is proportional to alpha, sin alpha, and B is proportional to the sin beta, and C is proportional to the sin gamma. Here you must note that when the force A is considered, then the angle between the other two forces, that is B and C, the angle between the B and C, that is alpha to be taken. And when the force B is considered, then the angle between the other two forces, that is the force A and force C, that is the beta is taken. And in case of the force C, the angle between the other two forces, that is A and force B, that is gamma, is to be taken. So therefore, the A is proportional to the sin alpha, and B is proportional to the sin beta, and C is proportional to the sin gamma. And ultimately, if we know here what is happening is, if we take a constant, so this is nothing but the A by sin alpha is equal to some constant, and B by sin beta is equal to a constant, and C by sin gamma also is equal to constant. So that constant are equal. So therefore A by sin alpha is equal to B by sin beta is equal to C by sin gamma. So this is the equation, and this equation is called as the Ramis theorem. So here we must note that A, B and C are the forces, and alpha, beta and gamma are the angles. So alpha is the angle between the B and C, beta is the angle between the A and C, gamma is the angle between the A and B. That means whenever a force is considered, then the sign of the angle between the other two forces must be considered. And according to this Ramis theorem, A by sin alpha is equal to B by sin beta is equal to C by sin gamma. So this is a very important equation. So it's generally called as the Ramis theorem. And this Ramis theorem is applicable when three forces are acting on a body and are in equilibrium condition. All the three forces are acting in a body and are in, the forces are in equilibrium condition. In that case, this Ramis theorem can be applicable, and with this, suppose if any one force is known and the angles are known, then we can able to find out the other two forces, or in some cases the angles can be, if the forces, all the three forces are known, then we can able to find out the angles like this. So here in this case what is happening is, the A, B, C are the forces, and alpha, beta and gamma are the angles. And this Ramis theorem can be useful to find out the unknown forces when some known force is given, and we can able to find out the unknown forces if we know the angles. Sometimes the forces are given and some angle is given, and we need to find out the other angles, that is the angles between the forces. And this the practical application of this Ramis theorem is nothing but we'll be finding in so many cases. The first example is, uh, we can say dead weights are three dead weights are hanged from the three threads, and when the threads are meeting at a point. So in that case also we can able to find out this Ramis equation to find out the tensions in the strings when that dead weight and opposite angle is known, like that. And also in case of crane, when the crane is lifting a weight, so it is having the some wires, and it is having it is subjected to some kind of tension. So in that case also the tension in the strings can be found if we know one of the angle and the force acting to that opposite side of that angle. The force acting opposite side of that angle. So like this, we got so many applications in the engineering field to find out the tensions in the strings and forces acting in the threads or the members when the one of the force is known and some angles are known. Now, so this is about the Lami's theorem, and now we'll go to the, so this is the mathematical equation is A by sin alpha is equal to B by sin beta is equal to C by sin gamma. Now we'll solve one of the problem here. This is the problem on the Lami's theorem. So we'll solve this problem to have the better understanding of this Lami's theorem. So take down this problem. Three forces acting on a particle are in equilibrium. Angle between the first two forces is 90 degrees, and that between second and third is 120 degrees. Find the ratio of the forces. Here, this is a problem given, and even the force value, even one of the force acting also not given, but only the angles are given. So with this, he is asking to find out the ratio of forces. So the ratio can be found. So in this way, here what is given is there are three forces acting, and they are in equilibrium condition, and the angle between the first two forces is 90 degrees, and that between the second and third forces is 120 degrees. Then we need to find out the ratio of forces. So very simple. So we have to take the three forces. So let the three forces acting on a particle or on a body are P, Q and R. Here P is the first force, Q is the second force, and R is the third force. And as per the problem given data, the data given in the problem, the angle between the first two forces is 90 degrees. That is, the angle between the P and Q is 90 degrees, and the angle between the second and third forces, that is Q and R, is 120 degrees. So first 90 and 120. So we know that the total angle is equal to 360 degrees. Here we got 90 plus 120. The value is equal to 210 degrees. So the remaining angle is equal to 360 minus 210. That is equal to 150 degrees. So like this, we have to find out the third unknown angle. The third unknown angle is equal to, when one is 90, the other is 120. The third unknown angle will become the 360 minus 90 plus 120. That becomes 150 degrees, because the total angle is 360. So in this way we have to find out the third angle, that is equal, in this case the third angle is equal to 150 degrees. Now, now the forces are shown and also the angles are given. Now, according to the Lami's theorem, from the Lami's theorem, the we know that the P by sine 120 is equal to Q by sine 150 is equal to R by sine 90. So once again I am repeating the force P by, we know that we don't know the forces P, Q and R, but only the angles are known. Now just find out the ratio here. So according to this Lami's theorem, the force P by opposite sign of the angle between the other two forces, that is the Q and R, that is P by sine 120 is equal to Q by sine of the angle between the P and R, that is 150 sine 150 is equal to R by sine of the angle between the P and Q, that is equal to sine 90. So therefore P by sine 120 is equal to Q by sine 150 is equal to R by sine 90. So first we will find out the P by Q ratio. So in this case, so we have to equate only first two equations. That is P by sine 120 is equal to Q by sine 150. So if you substitute that value, so P by Q is equal to sine 120 by sine 150. So sine 120 by sine 150, nothing but the sine 60 by sine 30, and its value is equal to 1.73. So therefore the ratio of the P by Q is equal to 1.732. Next, by equating the other two forces, now we have to equate the second equation with third equation, that is the Q by sine 150 is equal to R by sine 90. So Q by R is equal to sine 150 by sine 90, that is nothing but the sine 30 by sine 90. So sine 30 value is 0.5 and the sine 90 value is 1. So it becomes 0.5. Therefore we got the ratio, that is P by Q is equal to 1.73 and Q by R is equal to 0.5. So from the first equation, P by Q is equal to 1.73, Q is equal to P by 1.73, and from the second equation, Q by R is equal to 0.5, or R is equal to 2 into Q. So therefore we have converted the force P and also force R into the Q values. So we know we have converted the like this. Now let P is equal to X. Now therefore P is equal to X, then Q becomes X by 1.73 and R is equal to 2 into, because R is equal to 2Q. So when Q is equal to X by 1.73, R becomes to 2 into 1 by 1.73. Now the ratio means P is to Q is to R. So P, now we have assumed that the P value is equal to X. So P is equal to, if P is equal to X, then Q value is equal to, in terms of the X is equal to how much? Q is equal to X by 1.73, and R is equal to how much? In terms of the X, that is 2 by 1.73. So therefore P is Q is R is equal to that is x east x by 1.73 into 2 into x by 1.73. Now to have the relationship of the value, so we are multiplying with 1.73. So it becomes 1.73 into x and also only x and 2 into x. So the x is the some assumed value, some amount of quantity, the p value. So that x into 1.73 is the p value, and that x into 1 is the q value, and that x into 2 is the r value. Now because it is ratio, we are not finding out the exact absolute answer of the force, absolute quantity of the force, but we are finding the ratio only. Therefore the ratio of the forces, that is P east Q east R is equal to 1.73 east 1 east 2. So here the highest force is the force R and the lowest force is the force Q. So the ratio of forces are the P east Q east R, P east Q east R is equal to 1.73 east 1 is to 2. This is the answer for the problem. So in this way we are uh, supposed to work out the problems. So now let us stop at this point, and in this class we have solved the problems on the resolution of the forces, that is the resultant by method of resolutions, and also we have learnt about the Lami's theorem, and we have known the equation for the Lami's theorem, and we have also applied that Lami's equation or the Lami's theorem to solve a problem to find out the ratio of the forces. So in this way we have found the ratio of forces, and anyhow the Lami's equation is equal to P by sin alpha is equal to Q by cos sin beta is equal to R by sin gamma. Here the alpha is the angle between the force Q and force R, and beta is the angle between the force P and R, and gamma is the angle between the forces P and Q. That is, whenever we are taking the force, the angle between the other two forces is to be taken. That you must remember. So this is about today's class, and we'll discuss the remaining problems and Lami's theorem in the next class. So thank you all.